Alrighty, hello everybody, and welcome to the Marshall W. Allworth Planetarium. My name is Brandon Slattery. I'm a student worker here at UMD. Back there, we have our awesome director, Jessica Rogers, who is again the director. She's a wizard around here. And out there, giving you guys all tickets was Allie, who is another student worker just like me. And welcome to our annual monthly Ask an Astronomer, which is going to be a 30-minute show that's just going to be basically just going to be an open forum. We're going to answer any and all questions that you guys have about astronomy, space, general science, and ask any questions, and we'll do our best to answer them as best as we can. We also do have a couple of pre-made slides that we can go over if no one has any questions, but we do like this to be an open forum, and we like this to be a big conversation as well. Yeah, so I guess that's really it. If also for the people watching on Facebook, because we do also live stream this on Facebook, again, please feel free to ask questions in the chat, and we will answer them as best we can. But I guess starting off, any questions to start off? I will gladly answer as much as I can, and if I don't know, Jessica back there will definitely know. Anything about just general astronomy? Yes, you're right there. Do I believe in aliens? Yes.
Oh my god,
I
this
do.
is one of my favorite questions.
So I think that when we talk about aliens, the alien question, that brings up a bunch of different things. Me personally, I think life in the universe is pretty common, but I don't think intelligent life is very common. So I don't think you're gonna see I would say like different alien species in like Star Wars, Star Trek, stuff like that, that's actually able to communicate with each other. I don't think that is very regular. While I think that something like very microscopic life, like tardigrades, for example, or other different types, or phytoplankton, plankton, anything like that, I think that that's pretty common in our universe. And in fact, I actually believe that we actually have some other life here in our own solar system with the Jupiter moon Europa. Europa is essentially going to be essentially like an icy moon. Think like Hoth from Star Wars, if you've seen the second Empire Strikes Back or something like that. It's an icy moon that has about a 2 mile thick ice sheet on top of it, and underneath it, what we believe to be up to a 60-mile deep ocean. Can't put that in words that make sense. Oceans here on Earth get to about 2.5 miles deep. So that ocean is about 30 times bigger than the ocean here on Earth. But to be fair, also the Europa is about the size of our moon, so a little bit smaller than our moon. So it is pretty it's a good amount smaller, but we do believe that it has up to about 2 times as much water here that we have here on Earth. But at the bottom of that ocean, we actually believe that there are hydrothermal vents, which is actually the birthplace of where life started here on Earth. So we believe that there is a good chance that some basic form of microscopic life exists at the base ocean of Europa, which does get us really excited. And we are actually planning a mission called the Europa Clipper for launch in about, I think, October 2024. They haven't set an exact date yet, but yeah, to send a satellite to take some essentially just some samples of the icy moon, and hopefully we'll get some positive signs that aliens are there. That'd be pretty cool. Any other questions? Because if not, then I'll. Really? What's up?
Yeah. One of our Facebook watchers would like to know what is.
Oh.
And I have been thinking about that answer. I've been thinking about the question since I read it a couple weeks ago. And I'm going to be perfectly honest. I don't know. I think my first guess would be a nebula. So a nebula is a giant gas cloud in space. There are
if you look right there
along the walls, and our system is really colorful because it's a bunch of different elements that are spewed out during the death of the star, and those elements when they're hot all glow in different colors. So I think I'm gonna answer with nebula.
I would honestly probably say like a planetary nebula, probably. So that's going to be like this one right here. This is specifically the ring nebula right there. Those are typically quite colorful. Either that or star forming regions with like the Orion Nebula, the one that I pointed out a little bit earlier. Those are very colorful and very, very beautiful. Maybe even some exoplanets though too, Jessica, because they have some very wide range in what they can look like.
That is true.
I think of like 55 cancri as a pretty good example.
That is the ring nebula.
As you can see, very, very colorful, very pretty.
Yeah, and all of the different colors. I think exoplanet is a good answer as well.
For anyone not aware, exoplanet is going to be any planet that's outside of our solar system. So there's quite a bit of them. We've had, I think I mean, in our Milky Way galaxy alone, is it about half of the stars in our Milky Way galaxy we believe have planets? At least. To put that in perspective, there are about 200 billion stars in the Milky Way alone. And that would mean that about 100 billion of them have planets. And was it, I don't remember if it was a third or a quarter have a similar, what's it called? Have Earth-like planets.
Our current statistics estimate about 20%.
Okay, so I was being generous, which is still, like 20 billion planets.
Yeah.
So
20% is still a lot.
So that's a lot. Yeah. Probably 55 cancri. That's the one I would probably go off the top of my head. It's a planet that's really, really close to its star, and let's just say it's entirely covered in lava. So if you've seen Star Wars, the planet where like Obi-Wan and Anakin fight on, it's very similar to that. Pretty cool. I don't know if Jessica, you have a different answer than me. It's a,
all of these on the slide.
it's a contender at the very least.
I think I don't remember I don't remember the name of it. But there's one that has such a hot atmosphere that it actually rains molten glass.
Oh yeah.
And the wind is so strong that the rain is actually fully sideways. So that might be my contender for the most dangerous. I'm not taking into account though the exoplanets we know of that spiraled into their star.
Yeah.
And were destroyed. Those are not a thing that one can be on.
Since it's so dark, if you have questions, just feel free to shout them out. Yeah, you back there. Oh, absolutely. And I'm going to hand that over to Jessica.
Yes, I expected to get asked about this since it is all over. The question was about the super blue moon, which I just so happen to have some info prepared for this. So when hearing about the super blue moon, you probably have seen pictures like this, or pictures that have the moon in some sort of so, about what super and blue. Let's start with blue. First off, the moon is not going to be blue. It's not actually going to be blue color. The term blue moon refers to second full moon in a month, which usually happens about once a year. Since we generally have 13 full moons in a year, one of the months must double dip. So this year it happens in August. This is our second full moon in the month of August, so it is a blue moon. Now, super blue moon. The super refers to how big the moon is going to appear in the sky. So the moon's orbit around the Earth isn't a perfect circle. It's slightly elliptical, which means sometimes of the month it's a little bit closer, and sometimes of the month it's a little bit further away. The supermoon refers to a full moon when the Earth, or when the moon is closest to the Earth. Being closer, it's going to appear bigger in our sky. Not too much bigger. It's about 7% bigger than the average full moon. So unless you really know what you're looking for, you may not even really notice the difference. But that's what a supermoon is. The reason the super blue moon is getting a lot of attention is just how rare it is to have both things at the same time. As I said, a blue moon typically occurs about once a year. Supermoons typically occur a couple of times. The rarity is just having them both occur. And it's really not that rare, but of course, media likes to hype up a lot of events. So it is really cool, and it is cool that it's happening. But that's what those terms mean. Full moons is nice. A lot of people, I think, when they hear super moon, expect to see the moon a lot bigger. They're tending to look out at the moon as soon as it rises, and there is actually an optical illusion that makes it seem like the moon is a lot bigger when it's closer to the horizon. And that's because you have other things to compare it to. Like you can compare it to the size of a tree or a building, and it's easy to see how big the moon actually appears. And then once it's above the horizon, it's the same size as it was when it was on the horizon. You just lost your comparison. So it doesn't, you don't perceive it as big. So I think that's also where some of the extra people are going out to look at it right when it rises, right when it's on the horizon. So they're getting tricked by this optical illusion. So much bigger. When really it is in fact just an optical illusion. My long-winded answer to what's up with the super blue moon.
Any other questions now? Anything? Yeah. Keltonine Bias. I think. Yeah. I'm not sure. That would be a great question for Jessica back there. Do we have it in Digistar?
Yeah, we do.
We'll pull it up, and then we can take a look-see at it.
Oh, no, Moonrise. Oh, my mic died. It seems like. Oh wait, no, there it goes. Okay. Sorry, troubleshooting lots of things back here. Yes, Kelp 9b is an exoplanet. Let me look that one up in our system. There it is.
When is Moonrise tonight? When? That's a great question. I'm not sure off the top of my head. Let me look it up though.
I have an app for that. So Moonrise tonight is 8:09 p.m.
Yeah. A bit less than an hour.
Here. Okay. So this, get the lights back down, is Kelp 9b. Now, I do have to add, for these pictures we have of exoplanets, they are our best ideas of what they look like, because we don't actually have good pictures of these planets, but based off of their size and their mass, we can estimate what type of planet it is. And based off of the temperature, which we can figure out by how close or far away it is from its star, we're able to figure out other things about it. Like the one we previously saw, cancri, 55 cancri E, we know is like a lava world because of how close it is to its star. So Kelp 9b is bigger than Jupiter. It's almost 3 times the mass of Jupiter, but not too much bigger in size. Believe it or not, planets don't actually get much bigger than Jupiter, because at that point, all the stuff just continues to get squeezed in tighter and tighter. So even though you keep adding more stuff, it's squeezing itself in, so the planet itself doesn't actually get much bigger in size. Yeah, that's
How hot? That's a great question for Jessica.
What is it? About 1,000 degrees.
Pretty hot.
Yeah, it's pretty close to its star. It takes about a day and a half to complete one orbit around its star. So while we take 365 days, this planet takes about 1.5 days. So it is really close to its star.
Yes, you're right there. The farthest away thing that we've discovered, that's going to be, I guess, there's like two different things we can talk about: discovered versus like what we've like fully like determined. The farthest away thing is going to be is it the cosmic microwave background? Is that what it's called, Jessica?
That's where I'm going right now.
Which is going to be essentially a trace amount of essentially the leftover of the Big Bang that we can see, and it is far. And in fact, as we're going to look out, that's our Milky Way galaxy right there. And as we go out, we're going to see a couple more galaxies eventually. There's a lot of buttons, and there's a lot of galaxies out there. So this is just a handful of the galaxies we've discovered. And as we go even further out, we will see that there are even more galaxies out there. So as you're kind of looking at that, you may see that there are two sides that are kind of that are like kind of blank in it. And that's not because there is a galaxies there. That is because that is where our Milky Way galaxy blocks. All of those dots are separate galaxies. Each galaxy holding billions upon trillions of stars. And each star most likely having a planet of some kind. So our universe is big. So big, it's incomprehensible. And then if we go just a little bit further out, we can see this thing, which I'm actually going to hand over to Jessica because I don't really understand it. I'm not going to lie.
So this is the cosmic microwave background. It is the most distant thing, I guess, that we have ever. What we're seeing here is essentially. Okay, I'm going to use the webcam mic. What it is essentially the heat from the early universe. What we're seeing is heat from about 300,000 years after the Big Bang. Now, this is the earliest that we can detect light and detect anything. There were no stars or galaxies at this point. We're literally just seeing heat. But we can't see anything before this because the universe was so dense that light couldn't freely travel. As soon as it got emitted by something, it was immediately absorbed again. So this represents the first time that the universe was cool enough for light to travel freely, and we end up seeing this light coming from all over, which represents the heat. Because think of like when you feel the heat of the sun, what you're actually feeling is infrared light coming from the sun. So heat is just how our skin reacts to light being absorbed. And so we see that it's not perfectly even. We can see that there's like little differences, and that's showing us small little differences in temperature, which is actually small little differences in density. You have areas that have a little bit more stuff closer together and areas that have stuff a little bit more spread apart. And so this little bit of variation you're seeing is eventually what created the galaxies and the universe as we know it today. Each of those little dense clusters, each of those little dense clumps, eventually collected into a galaxy. So this little variation is what eventually led to the universe as we know it today.
Any other questions? Yes. Most dense exoplanet? Whoa, that's a big question. I'm not sure off the top of my head. You have any ideas, Jessica?
I know that.
That'd be it.
First, get us back.
Great view.
Okay. Whoa. What happened? This is me trying to run too many things at once. You go away. And you go away. And what the heck? What is that? I don't know. Okay, bringing this back. I just read earlier today of a new exoplanet that was recently discovered by TESS, which is our newest exoplanet satellite. That is, I think, is the densest planet we've ever found. And it is really, really weird. Like, we don't understand how a planet that dense could have formed, because it's not just a small rocky planet like Earth is. It's actually a Neptune-sized planet that is denser than Earth, I believe.
Oh.
It's crazy. But it was just discovered. So we have a lot of information left to gather and a lot to learn about it. But I think that's the answer.
Yes, you're right there. Ooh, yes, we can. Absolutely.
Can you repeat that for me, please?
The night sky over to Luth without any light pollution, and you're kind of looking at it. Right
Yeah,
now,
let me get us
actually.
a little bit darker.
This would be it right here, actually. If we just got a little bit darker, though. But we can kind of, yeah, you can kind of see everything. We have our beautiful Milky Way right there. I would say that's probably the best example of how dark you can really get is if you can see the Milky Way like naked eye. That's when you're like, okay, this is real dark sky territory. This is like boundary waters territory. Um, Another great way to I personally another great way to see if you're really in great dark skies would be looking for this right here. That is going to be the Andromeda Galaxy, the closest galaxy to us. Typically, the easiest way to find that is going to be find these 5 stars right there, which is the constellation of Cassiopeia, and which is Cassiopeia the Queen or Cassiopeia. Both ways to pronounce it are correct. But we can use the first 3 stars in the constellation to make a bit of an arrow that point directly to the Andromeda Galaxy. And that galaxy is quite big, but that's a great metric for seeing how dark you can really see, in my opinion. I don't know if, Jessica, you have a better answer.
No, I think that's pretty. I think that's pretty much.
It's this is not all the stars that like are out there. There are more stars, but like a lot of them are so far away that like you can't even really look. I will also say, the issue, what like this is a great view of it, but if you really want a even better view, that would be with our star wall that's in the middle of our room. That's going to get you a much more accurate view of of how dark our night sky can get. But also remember, all that haze right there is light from literal billions of stars. So it's a lot of stars.
You showed this compared to the view from the middle of the Pacific, say, from the top of the rock, it would be, you think it'd be very similar.
Yeah, so what we're seeing here, this is no light pollution. This is what we would see in a good dark sky. You really can only see a couple thousand stars in the night sky. Yes, there are, as Brandon was saying, 200 billion stars in the galaxy, but we're really only seeing the closest and brightest stars to us.
No matter where on Earth you are?
No matter where on Earth you are. You may see different sets of stars, because depending on where you are on the Earth, you're going to be looking at a different part of the sky, a different part of the universe. But you're still going to see roughly the same amount.
Yeah. Any other questions? Yeah.
This is our night sky. Hold on, I can put up.
Am I facing what direction?
North. You can tell because we have our Big Dipper right there.
Yeah, north at about 10:18 tonight.
Yeah. Tell me something interesting about Trappist 1. I'm going to hand that over to Jessica. I love Trappist 1, but I feel like Jessica knows more genuine, interesting facts than me.
All right, let me...
But we are going to fly to it.
Set us on our flight path over there first.
Great question, though, because Trappist 1 is a wonderful star. Oh, I forgot we got updated images. I completely forgot. That's awesome.
Yeah. So, Trappist 1 is a really, really cool system. It has... Why is my navigation not working? Come on. It has several planets. Hold on. Why is my navigation not working? Braden, why are we having so many technical issues?
I'm not sure. I think it's because it's our first Ask an Astronomer in person. So we are usually our digistar system is a lot more polished than this. We apologize, but
yeah, this is on the fly, having to look things up rather than having a show with everything compiled.
Yes.
Why? It's fine. It's fine. It's fine. You just see everything that goes on while we're creating shows.
Yes. That's
There
the
we go.
fun of Wednesday shows, though.
All right, so this is Trappist 1. It has stop orbiting. 1, 2, 3, 4, 5, 7 planets.
Yeah, 7.
And the cool thing about it is all of these planets are I just dropped the controller, roughly Earth-sized. They're more super Earths, so they're a little bit bigger than about 2 to 3 times bigger than our Earth. But what makes it really exciting is a lot of these planets are close enough to their star that they're in what we refer to as the Goldilocks zone or the habitable zone. That just means the temperatures are just right for there to be liquid water on the surface or for the planet to be Earth-like. And we have quite a few of the planets in Trappist that fall either in or very close to this Goldilocks zone. And that's one of the reasons that there was so much excitement over the Trappist 1 system, because it was the first time we had found so many possible Earth-like planets in the same system. And that was really cool and really exciting. So yeah, that's the Trappist system.
Yeah.
All right, I think we have time for one more question.
One more question. Anyone else? Feel free to shout it out. That's a really good question.
Can you repeat it for me? It's a lot quieter back here.
The central location for where discovery of stars happens. There's a lot.
So there's not really a center or a group that's doing that. I mean, most of the stars in our galaxy we're fairly certain we have seen and cataloged. But if you have a new telescope survey that points the telescope to an area of sky and finds one that isn't cataloged, then it gets added. So there is no real central organization that's working on finding all of the stars. At this point, it's just something that if you happen to find another one, it gets added. Same thing with galaxies. A lot of the galaxies, like you saw earlier, all those little pinpoints were galaxies we know about. So with things like James Webb Space Telescope, since it's able to see galaxies fainter than other telescopes have been able to see, it'll just add what it finds to our catalog of galaxies. So it's really more of just individual researchers or organizations, as they find things get added to the catalogs.
I would say exoplanets more lately has had a bit more of a designated search than
Yes.
general stars and galaxies, because there's a lot of stars and galaxies out there, but there are exoplanets are hard to find, are more hard to find. So, a bit more. That's where our efforts have been a bit more.
I'm going to do one last because I just saw it on Facebook, and also it's my mom, so I'm biased to letting this answer go through. And she's asked about Ingenuity, which is the little helicopter that is flying around Mars right now. It landed with the Perseverance rover, and Ingenuity, or we nickname call it Jenny sometimes. Jenny is still flying strong. It's up to, I think last I saw, like 45 flights on Mars. It's doing amazing things and proving that there's a lot that can be done with flying crafts rather than just rovers, because it's able to scout out locations for the rover. It's able to get images of places that the rover can't get to. So it's been really, really beneficial. And it's still insane to me that we sent it as a proof of concept. Can we fly something on Mars? And we were hoping for like one successful flight. And now we're sitting here at almost 50 flights. It's amazing. And yeah, if you are a Lego fan, by the way, Lego just dropped, or I think it's actually dropping tomorrow. I got mine early. Is dropping a Lego of the Perseverance rover, and it comes with a little Ingenuity copter as well. It's amazing. So if you're a Lego fan, definitely look into that because it's been fun. I started putting mine together last night.
I will also say, if you're just a Lego fan in general, there are so many great space sets, and a lot of them are more focused on just looking as good decorations lately. So I would highly recommend just checking them out. They're pretty cool.
Yeah.
I picked up a couple myself.
All right. Well, I think we will bring that to the end. I apologize for the technical issues. Again, this is the first time we have attempted this show in person. Normally we do it on stream. So hopefully everyone still had a good time. Come back for other shows. We do these free Wednesday shows every week. And yeah, we're still around if you still have some questions that you'd like to be answered. But thanks so much for coming.
Yep. Of course. If you just want to ask us more personal questions, feel free.